Students, welcome to my kitchen. Today we're going to talk about different methods of separation when you're separating mixtures and solutions, mechanical mixtures and solutions. But let's get things started with my cup of coffee. Coffee. Well, that's interesting that I'm starting with a cup of coffee because there is a method of separation that's involved in making coffee, and we'll get to that in a minute. Oh, nice. Well, let's come on over here. We're going to look at our first method of... Oh, what's this? Somebody left this trail mix on the counter. I think I'll start my morning off with some yummy, what do we got here, walnuts. Nice. What's this? Chocolate chips? Oh, I'm going to get a few of those. Chocolate chips. My favorite. Oh, what else we got here? Oh, raisins. Yuck. I'm going to leave those ones behind. Well, this is a mechanical mixture. You can tell because there are distinct parts in this. And one way of separating mixtures is manually or by hand. You can also pick things out with tweezers or whatever to separate a mixture. So I'm going to separate this mixture right now. Nice. Oh, that was good. I love that. I'm sure somebody else will eat the rest. Okay, but what if you have something that is too time consuming, or if it's too small to separate by hand? Let's say, for example, somebody gets rice in your flour. Nothing more upsetting than that. Look at this. You got rice in the flour. That's so upsetting. Well, for this purpose, we can use a sieve. The sieve has holes in it that are small enough to allow the flour to pass through, but they will keep the rice from passing through. So I'm going to pour the rice flour mixture, which is again a heterogeneous mixture, a mechanical mixture, into the sieve. And these are all mechanical means of separation. So I'm going to give that a bit of a shake. And there, we're left with the rice, and we've kept the flour in a separate bowl. So we can use both of those items again. So this method is called using a sieve. Just a sieve. It's a type of it's a kind of the next experiment. Which brings us back to my coffee. So, what if you have a particle that is too small to be caught by the sieve, and you want to separate it from something else that is also very small? Well, we have what's called filtration. So this is my coffee filter paper, and what it's designed to do is it holds the coffee, the small little bits of coffee right here, which would normally pass through a sieve, and it lets the water run through it, and it takes through some of the material that's in the coffee without letting the coffee grounds go through into my yummy, delicious coffee. So the next form of separation is called filtration. Okay, so I'm going to show you another form of separation coming up next. And we'll talk a little bit more about filtration as well. So this glass here contains nothing I'd want to eat or put into my body. It's actually soil from out in my garden. It's made of largely organic matter. It's been biodegraded, so it's compost. What I'm going to do is I'm going to do a little separation experiment with this. First of all, I'm going to add some water. I'm going to get my spoon. I'm going to give it a good stir. If we watch this closely, you can see that separation is happening naturally in the water. There are some particles that are going to the top of the water. This is called flotation. There are some particles that are going to the bottom. That is called sedimentation. So what we're going to do right now is we can skim off the surface of the water from the items that are floating. So this is a method of separation as well, flotation. So certain properties of certain materials allows them to float because they are less dense than water. Things that sink are more dense than water and will go to the bottom. An important part of the sedimentation process is the decantation. So when we decant something, we just pour it out. It's a fancy scientific way of saying we pour it out. So what I'm going to do is I'm going to decant this into the liquid portion into this container. And I'm going to do it through a sieve. So I'm going to filter out the floating material as well. And what I'm leaving behind is the sediment. So the material that is left behind is the sediment. And that's how sedimentation works with decantation. So I create sediment and then I pour off the liquid that is at the top. I filtered out the items that were floating. That's the flotation process. And what I'm left with is still some pretty dirty water. I want to get my water back. So what I'm going to use now is, does anyone know? Filtration. I'm going to try to use filtration to get it back. So I'm going to get that coffee filter. I'm going to put it into my sieve and I'm going to decant this mixture in there. We're going to see if that makes a big difference. So look at all those little particles still going out of there that were at the bottom, and we're going to watch it filter through the filter paper. Well, it's coming through there and it does look cleaner, but I still would not drink that water. It does not look that clean. You can see the use of different methods of separation that would be used for making clean drinking water in third world countries, or even just in your own city. So let's take a look at this. We have some sediment still, we have some liquid that have been filtered, and it still doesn't look very clean. So that's going to bring us to the last form of separation, and this is called evaporation. So evaporation is problematic because it will only, what happens is when we evaporate the liquid, the water will rise off and it will leave the sediment or the other things that are dissolved in the solution, the solute, behind. The solvent will evaporate off. So I'm going to take it over here and I can pour it into my pot on my stove and I can evaporate, wrong one. I can evaporate the water and I'll be left with the solute, which is those little particles that have made this liquid turn this brown color. But what happens to the liquid? Well, it evaporates off like this soup pot here, unfortunately, and most of it is lost. You see on this lid of this soup pot, there are particles of water that are forming. This is where the water condensates again. So what's left behind in the soup pot as it thickens is all the yummy veggies and broth, and what's condensing on the lid is the water vapor. And so that's pretty much pure water on the lid of that pot. This process is called distillation. In science, you can have a device that actually distills liquid. It'll trap the evaporating liquid and it will cause it to run off into a separate container. So the final process that we were talking about in the kitchen is distillation. Okay, there's one more process of separation that I want to talk to you guys about. And what you're going to need for this, you're going to need a refrigerator magnet and a piece of paper. Oops. And then you're going to go outside into your driveway. Okay, Armor Heights. What I have here is sand, just simple gravel driveway sand, and it is on this piece of paper. It's on the top of the piece of paper, and it is a mechanical mixture. It contains many different minerals. It contains some organic matter, maybe bits of tree roots or leaves or little tiny sticks. And I just put a little bit of it on this paper. And what I'm going to do is I'm going to take the magnet and I'm going to run it around underneath the paper. And I'll tell you why I'm using it underneath the paper in a minute. So I'm going to attach it underneath the paper. And if you look closely, there, you can see that what I'm doing is I'm separating some different components of this mechanical mixture. Does anyone know what I'm separating out? Well, if you guessed iron or magnetic metals, then you are correct. So all the earth around us contains certain amounts of iron, and that's the kind of iron that goes into plants, and then we eat the plants and we get our nutrition from those plants. So this earth, like the sand in your driveway, is no different. And magnetism is the final type of method of separation that we're going to explore today. So separating those little pieces of iron from the sand is a great way you can experiment with and try this at home using just a refrigerator magnet and a piece of paper. Now I'm using the piece of paper because I don't want to ruin the magnet. I don't want the iron filings to stick to the magnet because they're really hard to get off those magnets. And you can't just wash them off because of the power of the magnet. So anyway, there you go. Okay, awesome armor. I'm back in the kitchen again. I just wanted to review with you the different methods of separation. So first, we were over here and we were using manual separation, where we picked different things out of a mechanical mixture. The next one we used was using a sieve, which is a type of filtration. And filtration uses a filter and it leaves behind what's called a filtrate. Now, the next one after that, we learned about flotation, we learned about sedimentation and decantation. So decantation is where you pour the liquid off of the sediment, so leaving the sediment behind. Okay, we also talked about evaporation, which was over here at the stove, and you can see where the pot is starting to boil there right now. And we talked about distillation, which is where that evaporated water, the solvent in a solution, is captured, leaving the solute behind. Finally, we showed magnetism. So magnetism using the magnetic property of some materials such as iron and nickel in order to separate it out from a solution as well. So you're going to have a chance to use all of these different types of separation in your next experiment, which will be next week. So bring your thinking caps and you're going to do some problem solving for next week. So I hope you enjoyed this video and I will talk to you later. That's all, folks.